We're going to model a plane's velocity, v in meters per second, on the runway at takeoff as a function of t in seconds according to this equation. Here's the velocity time graph corresponding to the model. It takes off at a speed of 50 meters per second, and the question we're going to ask is how long does the runway need to be? That's presumably a relevant question for both aeroplane and runway designers. Well, to start, we can use the model to find out the time taken to get to 50 meters per second by substituting in v equals 50 and then solving for t, divide by 8 and square to get a value of t of approximately 39 seconds. So to answer the question, we want to know the distance travelled from time 0 to time 39, and we find the distance by integrating the velocity, which is equivalent to finding this area. Here's our integral. Well, we have a power of t. T is raised to the power of a half. So we increase the power by 1, so it becomes 1.5, and then we divide by 1.5. Then we work this expression out, once for our upper limit, or boundary value, and subtract from it the value for the lower limit. We'll explain why in a second. The first part works out to be about 1300 meters and the second part is 0, so the runway needs to be about 1300 meters long. Note that it would be common to factorise out the constants in this calculation to simplify the arithmetic, like this, where the 8 and the 1.5 have been taken outside the bracket, but it all amounts to the same thing in the end. Now let's say for some reason we want to find the distance travelled in the last 10 seconds before takeoff. I don't know what this reason would be, but it illustrates the point about boundary values. That point is that what we now require is this area under the curve. Performing the integration gives this expression as before, but with different boundary values. If we substitute t equals 39, we calculate the area up to t equals 39. If we substitute t equals 29, we calculate the area up to t equals 29. The area from 29 to 39 is the difference, so it's the integral evaluated at 39 minus the integral evaluated at 29. So the boundary values for an integral tell us to evaluate the integral at the upper and lower boundary values and subtract to find the relevant area under the curve.